Okay, so now that we're back, is this triangle right angled? So whenever you're going to see a question like this, the first thing that should come to mind is I'm going to use that famous Pythagoras theorem, yeah. Okay. And Pythagoras tells us if you've got a right angled triangle, the longest side square, or what we call the hypotenuse, identifiable by drawing a line against where the right angle is. So I'm going to check what 9 square is, and if it's right angle, it should be equal to 8 square plus 5 square. Is that the case? 9 times 9, 81. 64 plus 25. So I don't even need to do the calculation. 5 plus 4 is 9. So I know this is not the case. So you just say this is not a right angled triangle, because the left hand side is different from the right hand side. Okay, you can just put. So that's how quickly you can check it. You don't even need to do the square root or anything. You just do 8 square. You don't even need to do the calculation. So rules for fractions. Cross and smile.
Yeah.
Yeah, or kiss and smile.
Yeah, kiss and smile.
Yeah, so if you do the, let's say we do plus. So if you add them, you get AD plus BC divided by BD. So that's if you've got them a plus. And if it's take away, it's AD minus BC divided by BD. A quick way when you add or take away fractions. Rule for multiplying fraction, you multiply the top and you multiply the bottom. AC divided by BD. And when it comes to dividing them, we changed the divide sign, yeah, and we flip the second one, DC. And we get A over B, which is AD divided by BC. And if you're not too sure about all these, what I usually tell my student is do something like, is that working? What's half of half? Half of a half is, so if you got pizza, cut it in half. Half the half, how much do you get?
Quarter.
A quarter. Yeah, that works. That works because 1 times 1 is 1, 2 times 2 is 2. It's 4, sorry. Whereas if you got a half plus a half, what's a half plus a half?
It's
Half a pizza plus half a pizza.
Sorry.
So 2 times 1, 2, plus 2 times 1, 2, divided by 2 times 2.
4.
2 plus 2.
4.
Anything divided by itself. Half a pizza plus half a pizza is 1. Okay, so just in case you can't remember, always try with simple things. Sometimes I tell folks, draw yourself a circle, think about your pizza and taking half of a half. Oh, that's a quarter of my pizza. If I add 2 halves, I get a full. Okay. So now we're going to solve trig equation, but remember what we were doing earlier on, we were doing tan x equal, let's say 2, and the question was solve between 0 and 360. So let's say they give us this time the equation tan x minus 2 equals 0. How can I rewrite this so that I've got tan x on its own?
Bring 2 across to the other side.
Or what we said, yeah, what we said was to get rid of the take away 2. What's the opposite of taking away?
Adding.
You add 2 on both sides. That just put the balance back into place. Take away, add, the 2 goes. You end up with just tan x equal 2. Okay, so that's how you would solve it. So tan x equal 2. Let's solve this. X, where is tan positive? So if you don't have the graph, you just do positive where it says all. I know this is C, positive here when it's 180 plus alpha. Let's find alpha first, or x in our case because it's both positive. X is inverse tan of 2, which is 63.4, and the other angle you just do 180 plus 63.4, which is our 243.4. So here they've given the answers to 1 decimal place. We quickly check within the range of 0 to 360, so our answers are correct. And you do have, if you were to look at it visually, 2 answers, one here and one here. Okay. Now, if you're asked to solve 3 sine x plus 1 equals 0, how would you do that?
Bring this 1 across first of all.
Yeah, so you take away 1 on each side. Then you end up with 3 sine x
Equals to 0, 1.
equal, remember we take it away?
Negative 1.
Negative 1. And then the second stage, to get rid of multiply, we divide. Because 3 divided by 3 is just 1.
Does the 3 represent the, I know this is unobvious, but is that the amplitude? Is that from like when the...
Yes. So basically, no, 3, yeah, 3 would be our amplitude. So if you were to represent this graphically, which we're going to stop doing, but this would have been 3.
Right.
You're right. This
Yes,
would have been 3, and you would still get 2. Or in our case, because we've got sine x equal negative a third, we just put sine x as if it was 1. But yeah, 3 sine x plus 1 equals 0.
Okay.
So you could say, for example, in this case, I've got 3 sine x, an amplitude of 3. But instead of starting at 0, I'm going to start at 1. Because I went up 1. Yeah, that would be my amplitude.
And
Then that goes to 4. And that would go to 2. Sorry, negative 2. What we're looking for is 3 sine x plus 1 equals 0 is those 2 points here where we cut. It's the x-intercept where we cut the x. That's what we're looking for, those 2 answers. Or you can solve it by saying sine x equal negative a third. So we're looking for these 2 points here. So we're looking for this point and this point there. So we're going to treat it as if we've got something positive. which is here. Once we find our alpha, we're going to do 180 plus alpha and 360 take away alpha. Yeah? So sine x equal negative a third. First quadrant of alpha, 19.5. Yeah, I would rather people write alpha, to be honest, because when you put x, it's a bit leading. Yeah, I'll change these. Where's the color? Because if you put x, it's as if you're giving x as your answer, but no, you're looking for the angle alpha first. And sometimes alpha and x are the same. Now the real x is at 180 plus alpha, and the other one is at 360 takeaway. And that is given to us by CAS, remember? Where is cos negative? In this region and this quadrant, because they're all positive here. So it's going to be 180 take away alpha and 180. Now, what did they say? Sine. What is sine negative? I'm thinking cos. Sine is negative at this here, 180 plus,
and 180 subtract.
and 360 take away. That's where sine is negative. So you can ignore that portion there. Remember, cast, C-A-S-T, positive, positive, negative, negative for sine. So you've got 180 plus and 360 take minus. That's about like what we've just done there. But 4 sine x minus 1, this time without any graphs, giving your answer to the nearest degrees. So 4 sine x equal 1 or sine x equal a quarter, positive, so that's easier. Sine is positive 180 minus, yeah, and here. So we're going to have x here and 180 minus x. So if we find x by using sine minus 1, inverse sine of a quarter, I get my first angle, 14 degree. X equals 14. And 180 take away 14 is 166. So we called it the first quadrant acute angle between 0 and 90. So they've looked for theta, we called it alpha. But at least you've noticed they've not used x. Okay, so it's theta alpha is just any. Plus VE just means positive. Sometimes you see people writing plus VE, it just means you've got a positive value. So sine x is positive, so the solutions are in the first and the second quadrant. Okay. Solution x equal 14 and 166 within 360. Past paper. Solve the following equation. 7 sine x minus 3 equals 0. So that is the typical question that you could get during an exam question. So first of all, we're going to solve this by saying that we're going to add 3 on both sides. That means 7 sine x equal 3, positive 3. Then we're going to divide by 7. That means sine x equals 3 over 7. Then I'm going to find x, but before I do that, sine x is positive, so where it says all in the first quadrant, and 180 take away. That's what I'm looking for. X is inverse sine 3/7. So make sure you type that in your calculator. I see too many people sometimes rounding the 3/7. No, just use your calculator. Is a great option. So that is 25.37. But if they ask us to do it to the nearest degree, you can just say 25 degree to the nearest degree. So 25 is my first answer, and the second is 180 take with 25. 135. Oh, sorry.
I feel 155.
155. Yeah. So two answers, and they're between 0 and 360. So easy mark to get, as long as you remember your cast diagram. Or at least if it's 2 marks, you should be able to get the first one. This would be 3 marks, by the way, because you've got to solve the equation first, so that'll give you 1 mark. Then you've got to find the first angle, and then the third, so that'll be 3 marks. So you can get 2 out of 3, even without remembering the cast diagram, yeah? So you've got other questions which are quite similar, but this time to get rid of the 3, I'm going to add 3 both sides. I get 2 tan x equal 8. Then I'm going to divide by 2. Then that means tan x equal 4. Cast tell me that t is positive at 180 plus x and at x. So x equal inverse tan of 4. So I'm going to give the answer to the nearest degree.
76.
76 degree. Yeah. Have you noticed, because they've not asked me to specify to what to give, I tell whoever's going to mark me, I've rounded this to the nearest degree. If you get that habit, you're never going to get it wrong, basically. And the other one is 180 plus answer, which is 256 to the nearest degree. Okay. Two answers, 3 marks. 1, 2, 3. Homework 2, 24D, question 1. It's only one question, probably quite a few there. Okay, page 280. So let's have a quick look through some of the questions. So it's just practice, guys. Same as what we've done. Make sure you put your cast diagram. I'm going to pick one. Maybe I should pick, yeah, I'll pick the hardest. I'll pick this one. So to solve this, this is how I do it. Because I've got negative 4 sine x, I'll move it on the other side to make me positive. So I get 5 minus 8 equal 4 sine x. Basically what I've done is I've moved 4 sine x on that side and 8 on that side. So that means negative 3/4 So sine x equal -3/4. Cast sine is negative where it's not positive. It's going to be here, 180 plus alpha, and at 360 minus alpha. Alpha being in that first quadrant is sine -1 of this if it was positive. So shift sine of 3/4.
48.59 or 48.6 if it's
Yeah,
one
so we're
decimal.
going to 48.6 to 1 decimal. And now I'm going to plug that back in here, plus 180. So my answer is going to be x equal, I'll do it there. I don't have space there. 180
228.6
plus 48.6, which is 228.6. And the other one is 360 take away answer 311.4.
Yes, I got it.
So that's how you do it. So what was the difficulty here? Maybe solving the equation?
Moving it around, moving there.
Yeah, moving that around till you
Mhm.
get it. So that's probably the most difficult part. But once you've got your cast diagram and you know that you're looking for the positive equivalent angle, then we should be okay. So that's the most difficult one from that lot, I would say. And F is quite similar. Okay. So I've just left some space. I'm not going to go through that one. Now, yeah, so the last part, I think you've got questions attached to that.
From the first.
Yeah, from the first exercise, actually, we've looked at this. So we should be able to rattle through this very quickly. Okay, so basically it's putting your sine signal from, in this case, 0 to 720, and that's twice 360. So it's like two signals or two waves. And that means we need to find 4 answers for this one. So you get sine of x equal -1/2. So by solving this, so remember we take away 1 from each side first. And that means we've got -1 on that side. And then we divide by 2 after that. So you end up with sine x equal. So if you were to look at the graph from 0 to 720, we've got 1, 2, 3, 4 answers to find. But we need to find the positive answers first. And then we're going to add it to 180, take away from 360, and then move them across by adding the period to them. So x equals 30 is my first. So if you do inverse sine of a half, I would get 30. And I'm going to call this alpha. That's what we've been using. Now x is going to be 180 plus alpha. So you just put your cast diagram again. It's always good to double check it that way. So sine is negative in here and here. So 180 plus alpha and 360 minus alpha. 210, 330. Further solutions at 360 plus 210 and 360 plus 330, which is 690. And I can quickly check that they're all under 700 120. So my answers are plausible answers. Okay. So we've got some examples. We're not going to go through them all. What I can do, let's do one together. Let's do this one, right? Because I like it when I've got these. Oops. Is that white? We're going to do the last one. That's maybe the hardest one there. So if I'm given 5 cos x plus 1 equal negative 1.5, I just write 5 cos x equal negative 1, negative 1.5. And that is negative 2.5. Yeah?
Yeah.
Can I write this as a fraction?
A quarter. No, 5/2, sorry. Nonsense.
And I'm going to tell you why I'm writing it as a fraction. So I've got 5 cos x equal negative 5/2. What do I do next? Divide by 5 both sides. So when you divide by 5, it's a bit like divided by 5/1, which is multiplying by 1/5. Do you see what I mean?
I think so.
So basically what I've just said is because you're dividing by 5 both sides, it's a bit like divided by 5/1. 5 divided by 1 is the same as 5. Yeah?
Yeah, yeah. So
That would be negative 5/2 divided by 5/1. So what did we say we do to the divide sign?
flip it.
You flip, yeah, so you change the sign.
To multiply.
You multiply, but you flip this one. So 5/1 becomes 1/5. And now you can just simplify 5 and 5 because 5 divided by 5 is 1, and your answer is just -1/2. So we're looking for cos x equal negative 1/2. And we've done that before. Cas tell me that cos is positive, sorry, negative here and here. 180 minus alpha, 180 plus alpha. The equivalent alpha is just inverse cos of the positive half.
$60.
Yeah, 60 degree. So that's alpha. So we're not looking for alpha, remember, we're looking for x in the negative. So negative, we need to do x equal 180 minus 60, which is 120, and x equal 180 plus 60, which is 240, right? Mark, mark, mark. Do you think I'm done?
No.
Because I'm up to 720, so you just add 360 to all these answers. 120 plus 360, which is your 480. Another mark. You'd be surprised how much mark you can get with these kind of question. 240 plus 360. So 400 and 200, that's 600. Yeah?
Yep.
And you've got 1, 2, 3, 4, 5 marks for just this problem there.
You think that would come up in the exam? Just
No, this is a kind of tough question because you've got to work with fractions. So, and then that could put some people off. So they're not going to make anything as hard as this. Remember, this is from A to F. That's the hardest. That's probably the easiest. And then in between is what you usually get. Okay. But you can see the process. Because
Yeah.
once we got here, it's a bit, we managed to get into an easy one, but it's to do with dividing a fraction. But if you don't like working with fraction, you could have just tried negative 2.5 divided by 5. And if you struggle, then you can say this is negative 25 because I've timed by 10, divide by 5. But then whatever you get, you need to divide by 10. So what's 25 divided by 5?
5.
5. So minus 5 divided by 10 minus 0.5. So you could have done it that way as well if you wanted to. Yeah.
Yeah.
It's just try to minimize the, whenever you're going to get decimal points, you need to have a quick way in your head to either see this is 5.5 or time it by 10, but remember to divide by 10 afterwards. So these are the only tricks I would say, because unfortunately decimals are in the old days what we used to call fractionals, and they are always like an Achilles tendon for people. They find it quite difficult to manipulate decimals.
I'm one of them.
So you're not the only one.
Yeah, I know.
It's just trying to find ways. I know, because I went here and you might have thought, oh, this is even harder. But no, once you can work with fractions, you'll
I knew
see that.
when you divided them, that what to do. You know, I knew exactly what to do.
Yeah.
But getting from the first bit to the second bit.
We tend to, what happened, I've noticed, is you tend to go back to what you feel like, oh, I learned, the bus stop, parking the bus, I learned this at primary. Or maybe you did, but you need to remember that you've got a fraction here. So as long as you've got a way, you can say 2.5 divided by 5, 0 here, then I need to move the 2, and then remember to put the 0, then 25. So some people would find this much easier to go, because that's the way they've been taught from a very young age. But more and more you'll find out at primary, we stop teaching it this way. But like I said, if you got a way and you can get away with it, then use it. So F, we said 120, 240, 480, 600. So the answers are there for you after, okay? Last part of Unit 2 is what we called, oh no, I don't think I'll do this one. So it's not the last part, but cos square x equal 1. So if you're asked to solve cos square x equal 1, so again, this is more like when you get to higher, but you would try and say, I need to take the square root of cos squared to get cos. So I'm just going to go through it. It just means cos x is either 1 or negative 1. So you've got to, it's as if you've got now more than just one solution. You've got two solutions. So you've got to solve the first one. Where is cos equal 1? Cos equal 1 at 0 and 180. 0 and 360 for cos equal 1. And for the negative 1, it's going to be 180. So that's why you've got 3 answers. Okay. But don't worry. It's not something you will see. So if you're asked to find coordinates, remember coordinates are just, you're looking for x and y. So that's what they're asking us to find. X and y for P. X being the degrees. So once you find your degree, it's that x there, and y is 5. So basically solve this equation, find the two x's and replace them for P and Q. That's what they mean by this question. The two x that you find with y is always equal to 5. Okay. homework 24E, question 3, page 283. And then we'll finish with what we call trig identities. If anyone has heard trig identities before, you can let me know. Okay, page 283. Happy with that? I'm not even sure if Kirsty is here. Yeah. Okay. So
internet provider this weekend, I think Kirsty will be like straight on them.
This is driving me bonkers today. I'm honestly about to lose my rag.
You work from home as well, yeah?
And it's not been like this all day. So
nah, that's horrendous.
I know. So I'm just thinking what tomorrow's going to be like. Thank God you've recorded this. That's all I'm saying.
Good. So question 3 is only one question. So I'm going to let you deal with that one. And this is what we're going to finish with. So we're going to finish with what we call trig identities. So why do they call them trig identities? Basically, you've got a couple of things to learn when it comes to trig identity. The first one is learning this, what is the value for s? And then that tan x is just sine x divided by cos x. Those are the two trig identity that you've got to learn when it comes to trig. Okay, so apply them to solve some problems. I'm going to show you what the problems are. So if we were to investigate this, and I ask you, let's say we're at school, we'll investigate, you want to know for your student to have that in their head, you give them 4 or 5 different x's. So tell them try sine square of 10 degree plus cos square of 10 degree, and they'll find a value. Sine square of 60 plus cos square of 60, then they'll find a value, and so on and so on. And then they'll find, once they've done that, so pick one angle, and this is going to be a trig identity because every one of them should give you the same value. So pick one, try that. So remember, you type on your calculator sine. No, you need to do shift square, isn't it? Do we do square? So you can do square, sine of 10, close bracket, shift plus cos 10, close bracket, square. So what did you get for value? So you do sine 10, close bracket. Then
you do the sorry, on your calculator, how do you do the squared sine square?
So you type sine first, you put your angle. So I'm going to pick 50. You close the bracket. You need to close that bracket.
Right.
Once you've closed that bracket, then you press the x square button.
Right, okay. Got it.
And then you do the plus the same way you've done the sine, you do the cos. We're going to put 50 and then square. And when I hit equal, I got the same value. I've tried all these angles and I always get a value of, what did you get for the value?
I got 1.
Yeah. So
I got 1 as well. Yeah.
Every angles that we will pick, you will always get 1.
Yeah, I got 1.
So that's your first trig identity, to learn by heart. Sine square plus cos square is always equal to 1, no matter what angle you put. Obviously, they need to be the same angles, right? First trig identity. It does say there, learn. It's not given in your formula list, basically. So we can rewrite this. Remember, if you were to move cos square x on the other side, it's going to look like 1 minus cos square x, yeah? Or you can just say it's cos square x, you move sine square x on the other side, and it's 1 minus. But you only need to learn one of them. You don't need to learn all 3 of them. Yeah?
Yeah.
Because you just move one or the other, and you should always get the same answer, yeah? So what about tan? The way I tell my student to remember this is to use, because most of them would remember when we had sine, cos, and tan? There is a word that we made up. What was it again? Start with S.
Oh, SOHCAHTOA.
Yeah, so remember that SOHCAHTOA. So this is how I tell them to remember this, right? SOHCAHTOA. Okay, so sine is O divided by H, yeah? Do you agree? Cos is A divided by H, yeah? Opposite side divided by hypotenuse, adjacent divided by hypotenuse. And what did we say tan was again?
Over it.
So O, which is the opposite, divided by A. Yeah?
Yeah.
When you've got a fraction, an equivalent fraction would be you time the top by a number and you time the bottom by a number. And you get the same fraction, yeah? So if you got, I don't know, 1/2, you can do it's 2/4. It's the same value. But you can do the same by dividing both sides, both top and bottom by the same number. What happens if I do O divided by H at the top and A divided by H at the bottom? What is O divided by H?
Sine.
What is A divided by H?
Cos. So you're really just doing sine over cos.
That's it. That's your second one to learn by heart. Tan is just the sine divided by cos. And you can figure this out by looking at SOHCAHTOA. Okay? Sine over x divided by cos over x. So if you were to investigate again, I would ask you to put 10, 20, 50, few values of angles, and you'll try and you'll see that sine 20 divided by cos 20 is tan 20. Sine 45 divided by cos 45. Yeah. So sine 45 divided by cos 45. So I know that sine 45 is 1/√2. And I know that cos 45 is 1/√2. What's a number divided by the same number? Anything divided by the same thing equal?
1.
That's it. So tan 45 should be equal to 1. So if you type tan 45, if you're in degree,
Yeah.
you should be equal to 1. Because sine 45 is 1/√2 or √2/2 if you were to make your denominator, if you were to rationalize that denominator. I think if you do cos 45, what is your calculator giving you? Yeah, so it gives you √2/2, which is the same thing, right? If you rationalize the denominator. Okay, so √2/2 divided by √2/2 is 1. So no matter what degree what angle you will pick, we'll always get this. But I would rather show my student that you can change a fraction and have an equivalent fraction if you divide both by h, and then they go, oh, okay, yeah, now I can see sine over cos, and they'll remember it this way better than trying a few numbers. Okay, so tan x is just sine x divided by cos x. Learn. Okay, so let's see here. Given that sine x equals 3/5, find cos x. So the first thing we need to do in this kind of exercise is to use one of our trig identity. So let me put that as a black pen. And the trig identity we said we could use is cos square x plus sine square x equal 1. And you can rewrite this like we said, cos square x equal 1 minus sine square x. Sine x is 3/5. Sine square x is 3/5 square. So if you solve this, remember when you put a fraction and you square it, you need to square the denominator, the numerator, and the denominator. So you get 1 minus 9/25. So this is 1/1. So you just do cross and smile, 25 minus 9 divided by 5, which is 16. So 25 minus 9 is 16. 16 divided by 25 is our answer. The question was find cos x, but not cos square x. So now, because it's a square, you need to square root. But because it's a square, you've got two answers. So if you square root cos square, you get cos x, and square root 16/25, you get 4/5. So that was the question. Cos x equal 4/5. If sine x is 3/5, cos x is just 4/5. Okay? By using my first trig identity that I've learned today, cos square plus sine square equal 1. Now you could be asked something in the line of cos x equals 6/10. Find sine x. We do the same thing again. Sine square is 1 minus cos square. So 1 minus 6/10 square, which gives me 1 minus, so 100 minus 36, that's 64. 64/100. So sine x is 8/10. So I've got sine x, I've got cos x, and what did we say tan x was? Tan is just sine over cos. So you just
x over cos it.
So you do 8/10 divided by 6/10. So you change that divide by a multiply, yeah? So this is becoming 8/10 time, but we flip this one, 10/6, yeah? Simplify 4/3. Eight over 6 or 4/3. So we've got all our answers, tan x and sine x, thanks to what we've used is that trig identity. Or you can write it as cos square plus sine square x equal 1. So remember in your calculator, you've noticed that you couldn't type cos square that way. So it's the same thing. So if you've got cos x square, mathematician will write them as cos square x so that they don't have to write so that is exactly the same thing. Okay, just in case you go, I was struggling to enter this, but those you would get the same answer. Now, with these trig identity, the type of questions that you might get asked is prove that the left-hand side is equal to sine x. Okay, so to do that, we need to use our trig identities. And the first one that comes to my mind, I've got a cos square here, and I've got sine cube here. Can I factorize with something that would give me sine square and a cos square? Yes, you can factorize using sine x. So what you do to solve this, you go on my left-hand side, I've got sine cube, which is the same as sine x times sine square x, yeah? Plus sine x times cos square x. So you could now factorize using sine x. So what happens if you factorize using sine x? Sine x, open bracket, sine square plus cos square. And what is your trig identity telling you about sine square plus cos square? What is this value equal to? First trig identity?
1.
1. So if I replace that with 1, 1 times sine x is just sine x, which is what I had on the right-hand side. So when you're asked to prove a statement, you look on the left-hand side of your statement, you deal with it, and you show that you've proven that because this is equal to 1, I've got what they've given me on the right-hand side. And that's how you get, this is probably like 2 marks. 1 mark for factorizing and 1 mark for making the statement. Okay? Easy enough?
Yeah.
So what I find is some people sometimes struggle a wee bit because of treat sine x as if it was a big X, basically. Especially when I use curly. I would rather use curly X rather than the X that way. So you solve them as if you treat them with big X's. So sine x would be a big X and cos x would be a big Y, for example. Knowing that big X squared plus big Y squared equal 1. Let's see another one. You could be asked to simplify this. But in order to simplify this, what you need to do is you need to replace tan x with its trig identity. Tan x we said was sine x divided by cos x. So I'm going to rewrite this as cos x times sine x divided by cos x.
Factorize from there.
So, but even before factorizing, I've got cos x times something divided by cos x. I can simplify this. Cos x divided by cos x is 1. I end up with sine x over 1, which is sine x. What's sine x divided by sine x?
1.
1. That's it. So simplify this. You've simplified it. Cos x tan x divided by sine x is just 1. You always get 1, no matter what value you're going to put here. But you could have seen it because cos x divided by sine x is inverse tan x. Could you see it? So if you write tan x as sine x divided by cos x, the inverse of sine x of tan x is tan minus 1x is the opposite, is cos x divided by sine x. Or tan to the power negative 1, for example. Yeah, I should write tan to the power negative 1 is probably better than inverse. And tan to the power negative 1 is just 1 divided by tan x. So you've got 1 over tan x times tan x is just tan x times 1, which is tan x, divided by tan x, and that is 1. So we could have got it from there. Or if you would rather change the tan x that way, that's probably easier to see, yeah? than the inverse, than tan to the power, because now you need to deal with negative indices. But if you remember our index lesson in the okay, so one last one before the homework. So I've got sine square A divided by 1 minus sine square A. So to prove that, the first thing I would do, right on the left-hand side what I've got, use 1 minus sine square A, sorry, 1 minus sine square A is just cos square A, yeah? Sine square A divided by cos square A. I'm not too happy with this. So this is wrong. This should have said tan. I'll fix that. Okay. So the question should have been, prove that sine square A divided by 1 minus square A equal tan square A, which is what we've done, right? So I'm glad we went through this. Last homework, and I'll let you get on with it. 24G. Page 288. These are just trig identity type questions. And they're all like practicing. So you've got 2 to learn and try and see where you can use them. Good?
Yep.
So question 5, 6, and 7. Guess what? There they are. We've probably done one of them. So just refer to the other 3 questions that we went through. So I'll send you this deck of slides, because I'm not going to do them with you guys. If I do them, it's basically you've got three questions. Okay, so use okay. So basically they're just trig identities for your last homework.
Just made it Kirsty in time. That's the only reason you came back on.
I know. So Kirsty, you can write these. And that'll be us for today.
For the long weekend for some.
I know. Oops. Did you manage to take this? I just hit the stop share instead of the stop recording.